Hi, in this video I want to introduce radical. What is a radical? The easiest answer is a radical is any expression that looks something like this. But let's start with a more basic definition. Let's look at where the word comes from. It comes from the Latin word radix, which means root. So if we were to look at an equation like 2 to the third power equal 8, if you kind of use your imagination, you could kind of imagine this 2 as being the root from which we get 8. However, you can't just turn 2 into 8. So this root needs to be raised to the third power in order to get 8. How we say this is 2 is the third root of 8. In mathematics, we often prefer not to write long sentences like this. We say this simply by saying 2 is equal to this symbol here, or this expression, which reads third root of 8. So when you read this, you should read this as 2 is equal to the third root of 8. And understand that as the number which, if we raise it to the third power, we get 8. So 2 is the root, which raised to the third power will give us 8. 2 is the third root of 8. It's important that we get what these things mean. So let's go over this again. What does this expression mean? We know how to say it. We say it's the third root of 8. But what does it mean? It is referring to some number, the root, which if raised to the third power would result in 8. Of course, we know that number is going to be 2. So what happens if you are faced with this expression here? Third root of 8 raised to the third power. Well, let's look at this. This is a number which, if you raise it to the third power, you're going to get 8. And what are we doing? We are raising it to the third power. So what should we get? We should get 8. I hope that is clear. Again, let's go over it. You have a quantity, this one, which you know if you raise it to the third power, you will get 8. You then raise it to the third power. Well, you have to get 8. In general, the symbol for the nth root of some number a is what we have here. This is the nth root of a. It's some number which, if you raise it to the nth power, you will get a. So these expressions are called radicals. And when you're given them just like this, we are referring to the positive root. Some of you may recall that the square root of 26. Well, there is a negative number that if you square it, you get 26, and there's a positive number that if you square it, you get 26. Just given a symbol like this, or an expression like this, we are referring to the positive root. This little symbol here, that's called the radical symbol. This number here is called the index. Remember, it's a power. And what we have under the radical sign, well, that is called the radicand. Let's look at these examples. The square root of 25 is some number which, if I raise it to the second power, I get 25. Note that in the case of the square root, we don't write the number 2. For all other roots, we write the power or the index explicitly. Here we have the cube root of 27. This is referring to the number which, if raised to the third power, will give us 27. It so happens that we know the answer will be 3. 3 times 3, 9 times 3, 27. However, I want you to not pay so much attention to what the actual number is, but rather to the idea of the number. It's some number which, if I raise it to the third power, I will get 27. Likewise, here I'm referring to some number that if I raise it to the fourth power, I will get 16. Yes, it happens to be 2. 2 raised to the fourth power will give you 16. But the important thing is that you understand the meaning. This is some number which, if I raise it to the fourth power, I will get 16. Let's do these examples. For each of the following expressions or statements, write the corresponding English expression. Notice we don't use your calculator and go, oh, square root of 84. Well, that is 9.165 approximately. No, what I want you to focus on is that this thing here is a number, actually. What number? It's the number that if you square it, you will get 84. What is this quantity here? Well, it's some number that if I raise it to the third power, I will get 51. What is this number here? It's the number which, if I raise it to the fifth power, I will get 462. What is this number here? It's a number which, if I raise it to the seventh power, I will get 3.54. And here, this is a number which, if I raise it to the 6th power, I will get 93. Here we have some equations written in radical form. Notice we're talking about equations, so be very aware of the difference between an equation and an expression. An equation has an equal sign, and it has an expression on the left and an expression on the right. Of course, this is just a plain number, so it's a very simple expression. So when I am talking about when I speak of writing a radical equation in exponential form, I mean this. This is saying that 2 to the 7th power is 128. Why? Because of the meaning of this. This thing means the number which, if I raise it to the 7th power, I get 128. That happens to be 2, so if I raise 2 to the 7th power, I get 128. Likewise here. This is a number which, if I raise it to the 4th power, I get 1296. Well, this happens to be 6. That means that if I raise 6 to the 4th power, I get 1296. This means the number which, if I raise it to the 3rd power, I get 1728. Well, it swaps that this is 12, so that means 12 raised to the 3rd power gives me 1728. This is the number which, if I raise it to the 6th power, I get 15625. This happens to be equal to 5, which means then that 5 raised to the 6th power will give me 15,625. And here, this is a number which, if I raise it to the 4th power, I get 65,536. This happens to be equal to 4. So that means that 4 raised to the 8th power is 65,536. What we have been doing is we have been taking equations written in radical form and writing the corresponding exponential form equations. But now let's look at these radicals themselves, the expression by itself. These expressions themselves can be written in exponential form. So now we're not going to write a corresponding equation, we're just going to change the expression. So let's see how we can do that. The square root of 9 is some number which, if we square it, we get 9. So this should be clear. Let's see where we can take this. The square root of 9 squared is 9. I want to find an exponential form of this expression. In other words, I want to say 9 raised to some power. If I take that and square it, I want to get 9 to the 1st power. So I'm writing the 1 here so you know that it's to the 1st power. That should be obvious, but I'm still just restating it here. So I can make use of a property of exponents that I know, that when I have a power to a power, the resulting exponent is the product of those powers. So I just need something here that when I multiply it by 2, I get 1. Obviously, that has to be 1/2. 9 to the 1/2 power squared gives us 9. We then have to accept that the square root of 9 is identical to 9 to the 1/2 power. In general, we can assert that a raised to the 1 over n power, where n is some integer, is equal to the nth root of a. Here we have something that if I raise it to the 3rd power, I will get 8. I raise it to the 3rd power, I must get 8. It should be very obvious that 8 to the 1/3 power, if I raise this to the 3rd power, I must get 8. 1/3 times 3 is 1. So then this is what we have here. 8 to the 1 over n is the nth root of a. Make sure you know this. We can take this one step further. Let's, in this case, square both sides. If I square both sides, I get, obviously, 8 to the 2/3, and I get this squared. What should be clear to you is that this can also be written this way. So let's just do a little example here so that you see. If I find the cube root of 8 first, that's going to give me 2. And then if I square that, I will get 4. Here I take the cube root of what? 64, which also happens to be 4. So this is not proof, but I think you get the idea that having the square of the cube root of 8 is the same as having the cube root of 8 squared. So we can take our identity one step further. I should have put 3 bars here, but I forgot. A to the m over n is the same as the nth root of a to the mth power. So make sure you know this. And don't just memorize them in a meaningless way. Make sure you understand it. Have a little example always ready in your mind so that you can see just how obvious this must be. So recapping, these are our two identities. Again, I should have put 3 bars here. So the nth root of a is a to the 1 over n. The nth root of a to the m power is a to the m over n. So let's do this exercise. Express the following using exponents. Well, obviously this is x to the 1 over 6. What will this one be? You should pause this video and do these and then check that you got the answers correct. Anyway, this should be a to the 5 over 4. This should be a to the 7. There is an invisible 2 here. That's a to the 7 over 2, y to the 7 over 2. This entire thing here is going to be raised to the 3 over 5. And this is going to be raised, well, underneath here, it's 2x plus 5 raised to the 1/2. But the whole thing is in the denominator, so it's the minus 1/2. Remember that 1 over a is a to the minus 1. So 2x plus 5 is going to be raised into the minus 1/2. We can do the reverse. Let's express these using radicals. X to the 2/5, well, that becomes a power and that becomes a root. All of this to the 1/2, well, that's simply the square root of that. To the minus 8/3, well, you know that this is like 1 over p to the 8/3. And then p to the 8/3 is the third root of p to the 8th power. Q to the a over b, well, that's simply the b root of q to the a power. And here, this is like 1 over the square root of y. So again, a quick recap. A to the 1 over n is the nth root of a to the m over n is the nth root of a to the m power. We are quite over the 10-minute mark, so I'll stop this video here and we'll continue with this topic in the next video. Till then, bye.